Okay, in this video we're going to look at how we integrate using partial fractions. So the first thing, we're going to just jump straight to the example. We'll talk through any problems as we get to them. So it says integrate 2x plus 7 over x squared plus 5x plus 6 with respect to x. So the first thing you would look for is you just check that it's not in the form f dash of x over f of x. So just differentiate this bottom line. You'll get 2x plus 5. And on the top line you have 2x plus 7, so it's definitely not in this form, so we can't just integrate directly to get a ln. Sometimes you could, so if it had this been 2x plus 5 on the top line, we could have just integrated this and it would have been ln of x squared plus 5x plus 6, and then plus your constant integration. But it's not in that form, unfortunately, so we've got to use partial fractions. Okay, so we'll just have a look at this. I'm just going to say, first of all, let the 2x plus 7, it was over x squared plus 5x plus 6, let it be equal to a over, and if you factorize this, but the bottom line, the denominator, you'll have x plus 2, and then b over x plus 3. So we're then going to look at the thing, and we're going to say, we're going to so we have got 2x plus 7 over x plus 2, x plus 3 is identically equal to, sorry, I should have an identical equal to sign here, is that identically equal to x plus 2 plus b over x plus 3. Now all we're going to do here is multiply across by the denominator being x plus 2, x plus 3, which will leave you just x plus 7 on the left hand side is identically equal to a upon x plus 3 plus b upon x plus 2. From here on in, it's just finding the values of a and b. So I'm going to do that by letting, first of all, let my x equal to minus 2. So if x equals minus 2, this bit will disappear because you'll have minus 2 plus 2, which is 0, and 0 times anything is 0, so this bit effectively disappears. On the left hand side, you'll have minus 2, 2 times minus 2 is minus 4, plus 7 is minus 3, is equal to minus 2 plus 3 is 1, so it's just equal to a times 1, so it's just equal to a. Okay, sorry, that should be plus 3. That should be plus 3 here. We'll just check that. 2 times minus 2 is minus 4, plus 7 is just 3, so it's plus 3 equals a. So you've got your a, and also we're going to say let your x equal to minus 3. So we have 2 times minus 3 is minus 6, plus 7 gives you just plus 1. And put minus 3 into this. Minus 3 plus 3 gives you 0, so this a term disappears. And then minus 3 plus 2 is minus 1, so that's minus 1 times b, so minus b. So your b is equal to minus 1. So you've got your a and you've got your b. So your integral is, so we'll just say, therefore, we're going to be integrating. Your a was 3, so it's 3 over x plus 2, and your b was minus 1, so minus 1 over x plus 3. And now we're good to go, because both of these things are in the form, or almost in the form, f dash of x over f of x. So this one, differentiate this bottom line, you get 3. So you'll get 1. So that's really 3 times bigger, so it's really 3 upon ln of modulus of x plus 2. And then this one is minus ln of modulus of x plus 3, and then plus c. Now, to be honest, I would be absolutely happy with it being left in this form, but just in case they ask you to, it's a show that question, they may ask you to do a wee bit more. So just say, or that is equal to ln of modulus of x plus 2 cubed. So what I've done is pull that 3 up here. Then we still have a minus ln of x plus 3 plus my c, which is the same. And then using your second rule of logs, log of a minus log of b, you can write that as x plus 2. That bit is being cubed. And then the bottom line is x plus 3. And that's it. Okay, so tricky enough for example. You've got a lot of places you can make a mistake in, so just take care. First of all, you've got to factorize your denominator. So that was x plus 2, x plus 3. And then solve your partial fraction, so find your values of a and b. And then you've got to integrate successfully. And then maybe you will have to tidy it up and write it as 1 ln. Okay, it's just another partial fractions example here. We'll just say let the 2x minus 1 over x plus 1 squared be identically equal to a over x plus 1 plus b over x plus 1. So this is one of the repeated denominator ones. And we cross multiply, so you'll have your multiply crossed by your x plus 1 squared. You'll have 2x minus 1 is equal to a upon x plus 1 plus just b. And again, we've got to find our values of a and b. Now, the last one I used the substitution method. This one I'm going to use equating coefficients. So I'm going to say equate coefficients of x to the power of 0. Now, this is one of the ones people rarely do, but x to the power of 0 just means the numerical terms. So on the left-hand side, my numerical terms, and numerical term is just minus 1. On my right-hand side, I have a times 1, so that's just a, and I have just b, so that is an equation. So maybe not what you're hoping for. You haven't actually found your a or your b doing this. But we'll just go on and we'll say equate coefficients, and we'll just go for x. On the left-hand side, you've got 2. On the right-hand side, you've got a times x. So now you've found your a. So just subbing back into, just say sub into equation 1, and that will give you minus 1 is equal to 2 plus b, which means minus 3 is equal to b. So therefore our integral becomes, I'll call that I just to make it a wee bit clearer. So therefore I is now going to be equal to the integral. My a was 2, so it was 2 over x plus 1, then minus 3 over x plus 1 squared. Okay, not so easy here. This first bit is actually very easy. It's the easiest bit. So just do it now while I can. It's going to be 2 times ln of x plus 1 modulus of, 2 times ln of modulus x plus 1. This bit here then on the right hand side, I'm not too sure how I'm going to have to do this one. I'm going to have a look at it, and I'm going to try raise the power by 1. I'm going to try differentiating x plus 1 to the power of minus 1 just to see what I get. If I differentiate that, I'll get minus 1 times x plus 1 to the power of minus 2, when I really was hoping that would be a minus 3. So I'll need to multiply that by 3, so differentiate 3 times x plus 1 to the power of minus 1. If I do that, I'll get minus 3 times x plus 1 to minus 2 as required. So I differentiate 3 upon x plus 1 to the power of minus 1, and I get this. That means if I integrate this, I will get this thing. So it's just going to be plus 3 times x plus 1 to the minus 1 plus my constant integration. Okay, tidy up just one last thing. I don't like that power being the way it is, so I'm just going to write 2 times ln of x plus 1 plus 3 over x plus 1 plus my constant of integration. Just put this in a wee circle to show that's separated, and that's it. Okay, you're now ready to do topic 7, and that's the integration B section, and then exercise 3. Exercise 4 is also there. You could use that for extension questions or a summary exercise of what we've done so far.